welcome back to the course. This is part C. I'm going to be talking about stoichiometry of solutions. I've talked about the mole concepts. I've talked about mass relationships. I've also talked about mass volume relationships. So we're going to talk about now stoichiometry of solutions. Alright, now when we talk about stoichiometry of solutions, we are referring to solutions we get. And normally a solution is majorly made up of what? A solute plus a solvent. Please take note that a solute may be a gas, may be a liquid, may be a solid, and also a solvent might be a gas, a liquid, or solid. Please take note. Don't just put it in your head that solvent must be liquid, solute must be gas. And both solute and solvent, they can exist as at any of the states of matter, that's gas, solid, or liquid. Do you get? So that's one thing. So let's talk about the formulas for molarity. Now when we talk about stoichiometry of solutions, we can't actually leave molarity out of it. Let me see if I can divide the board. Okay, can't leave molarity out of it. So molarity is defined as concentration in mole per dm cube. Then you can also write this as mole per dm cube. Right? Concentration in mole per dm cube is what we call mole per dm cube or mole. So it means if you see something like this, 0.025 mole per dm cube. This is called molarity, or 0.025 You get that's the molarity, concentration in what? Mole per dm cube. You also call it also known as molar concentration. You get also known as molar concentration. Meanwhile, molarity, please get the differences. This one is liti, this one is riti. You get this one is concentration in gram per dm cube. Or you can just do it like this, right? And it's also known as mass concentration. It's also known as what? Mass concentration. It's the formula that links both together. So you have that molarity is equal to molality all over molar mass. Just in case you want to link them, this is the formula. So if you are looking for molarity, just do molality. Remember that molarity is molar concentration, right? In mole per dm cube or this M. And molality is what? Mass concentration over molar mass. So you see the same thing. You get. You can just see this is concentration in mole per dm cube, or M is equals to concentration in gram per dm cube all over what? Molar mass. See everything I just showed, they're actually the same thing. You get, they're actually the same thing. So these are the basics when it comes to molarity. So you can actually convert. And the other thing I want to teach you is this. Remember that both molarity and molarity is always per dm cube. You get, always per dm cube. Always per dm cube. You get, it's not per cm cube. But there are sometimes they will give you molality, that's mass concentration, in gram per cm cube. How do you now convert to? Because look at it, the unit of molality or mass concentration is gram per dm cube. What if they're not giving you in cm cube? We have to convert it to gram per dm cube. You get, that's one of the problems that you likely want to face. So I won't tackle it on time, so you don't have the problem. So all you have to do is this. For instance, say you see a question like this: a solute of mass 25 gram is dissolved in 100 centimeter cube of a solution. What is its mass concentration? Let's just say this is example 1 plus solution, because I will solve it. You get? You see now. Now the question is, says a solid of mass 25 grams is dissolved in 100 cm3 of a solution. What is the mass condition? And just asking us what is the condition in gram per dm3. If you look at this thing, we have gram, we have cm3. So it means you have to convert cm3 to dm3. I did not come here with my calculator. It's well. Okay, so you have to convert to dm3. Please, let me quickly get my phone. 1 minute. Okay, so I want to confirm something first. Okay. Alright, so first of all, to convert from cm3 to dm3 divided by 1000 is something you should know. Alright, so let's go back to the question. A solid of mass, this is dissolved in this. What is the mass? What is the mass concentration? Now all you have to do is you just want to compare. You get? You just want to compare. Now please take note that 1 dm3 is equals to 1000 cm3. You get 1 dm3 is equals to 1000 cm3. Do you understand? So what does that mean? It means, if you look at it, this is how we compare. We say 25 grams was dissolved in what? 100 cm3. How many grams will now be dissolved in 1000 cm3 or 1 dm3? You see, this is just a simple comparison that you can do to convert gram per cm3, because this is gram per cm3 to gram per dm3. You get? It's very, very easy. It's what you have to do is look at it. 25 grams. You see, because it's so little amount of this and it's dissolved in this. Now, if 25 grams will dissolve in 100 cm3, then X will dissolve in 1000 cm3, because 1000 cm3 is 1 dm3. So what you just do is just multiply. This will be 25,000 equals to 100x divided by 100, right? So you now have that x equals to 250 grams per dm3. So you see how to convert. It's just as simple as that. You get it, it's as simple as that. So if they are giving you stuff like this that involves mass and then cm3, to convert it to dm3, just compare like this. That's 25 grams dissolved in just centimeter cube. Then s gram we get. Let's do another example first. So you get used to it. It's just taking it off it, because when you start solving complex questions, the thing is, this will not be the question that we ask you. The question that we ask you will involve you to do this thing. And that's when people will miss it, because they cannot do this. They'll go and work with the value they are giving the question. And like that, you're going to fill the questions you get. So let's do example 2. What is the molality of a solute of mass 100 grams dissolved in 250 cm3 of H2SO4? See, they're asking us to look for what? We're looking for what? Molality. Please take in that molality is equals to what? Mass concentration. That's concentration in gram per dm3. So what I'm doing is not different from what you did here. The only difference is English. English is not confusing. So they give us the mass, 100 grams dissolved in this. See, the simple, you just say, okay, if 100 grams of this guy dissolved in 250 cm3 of this guy, then S gram will dissolve in 1000 cm3. 1000 cm3 is empty as what? 1 dm3. You get? Just multiply. If you multiply, you have equals to 250x divided by 250 divided by 250. So we now have that x equals to 100,000 divided by 250. So then we do that one calculator. 100,000 divided by 250. This is 400 gram per dAq. See, very easy. Let's come back to this place. Now, this was the molality that we calculated, or the mass concentration that we calculated, right? Now, I want to ask you, what if they now said we should look, they will now ask a question that we should look, they now say what is the molarity? What is the molarity? Given that the molar mass is 25 gram per mole. What we use in this case, you see, now we have gotten the molarity. Then let's look for the molarity. It's easy, just know that molarity, what is molarity? Concentration in 𝗵𝗶 is equals to what? Molarity. That's concentration in gram per dm3 all over molar mass. Should you get? If I look for molarity, what I have to just do is this. Molarity, what is the molarity now? 250. What is the molar mass in the equation? 25. So we have 250 divided by 25. That is 10 what? Mole per dm3, or 10 mole. Use calculator. So you see now. So these are linking. This are linking. It's not hard at all. It's not hard. So just know the formulas. Well, about this case now, we have the second question that says, what is its molar concentration? See, the same thing that I asked us to look for here, because molar concentration is the same thing as what? Molarity. Now, we're looking at molar concentration. Remember that molar concentration is, I've mentioned this before, you should have put them in your book. It goes to mass concentration all over molar mass. Let me just type it out. Molar mass. Now, this is what we for the molar mass. But remember that from the videos that we're solving, the molar mass of H2SO4 is 98 gram per mole. You can check, calculate it by yourself. You will see it too. So this is the same thing as what? Molar concentration goes to mass concentration 400 all over what? 98. 400 divided by 98. We have 4.018 mole per dm3, or 4.0181. It's actually 82 mole. Yeah, but most times I have not really seen the value of molarity or molar concentration that will be greater than 0. It's always 0 point something something most times. Yeah, just because it's a rough work. So what I'll be able to do is to establish how you can convert gram per cm3 to gram per dm3, and how you can equally convert this gram per dm3 to mole per dm3. Please take now this same formula. If you are given the molar concentration, that's molarity. You can also easily convert it to molarity. It's just the same. You have to now change what you're looking for. You get, so that is it. So we have not started the topic yet. So this is just like an introduction for us to understand all these basic concepts. Alright, so let's see our questions, 3 questions under this 𝗁𝗔𝗔 of solutions are set. Remember, we are talking about mass-mass relationship, and we're talking about mass-volume relationship. Yes. We're talking about mass-mass relationship. Talk about mass-volume relationship. Let's see how this 𝗁𝗔𝗔 of this thing works. Now, the concept here is this. You'll be given a question. Okay, I can just do one. So let's go, example 3 now. Let me put the question. Let me drop an equation. Let's say HCl plus NaOH plus sodium chloride plus H2O. Let me balance 2 here, 1 here, 1 here, 1 here. It's balanced already. Let me put their states. Let's say this was aqueous, this was aqueous 2, this is solid, and this is what? Liquid. You get. Now my question is this: in the reaction above, what aqueous solution reacted with 3.65 gram of HCl. Given that H is 1, Cl is 35.5, sodium is 23, oxygen is 16. You see the question? I've just watched a very nice question. Now, we have gotten used to comparing stuff with their moles, right? What we just do is, normally if it was a mass relationship question or a mass volume relationship question, what you just do is compare that 1 mole of this guy to 1 mole of this guy. Then you convert this 3.6 to mole, and you look for what you're looking for. It's the same concept. Remember that I told you when I was talking about mole concepts, that number of moles equals to CV over 1000 if the volume is CM cube, or number of moles equals to CV if the volume is what? DM cube. See, that's the knowledge you're going to bring here. So let me show you how this one works. You still compare with the number of moles, right? Because we're talking about this guy. Let's see what is the correlation of this guy, and they gave this guy. So we're talking about these two guys. So you have to compare. We say 1 mole of HCl was actually reacted towards 1 mole of sodium hydroxide. So you get 1 mole of HCl was reacted with 1 mole of sodium hydroxide. You get. So we have to use this value now to look for the number of moles of HCl that was reacted. So you get. So number of moles equals to what? Mass over molar mass. Please, at this time, if you have watched the first video, so I will not be taking my time to calculate molar mass like that. So you can do it anyway. You don't get how I calculated molar mass, because I believe in the course of doing mass relationship and mass volume relationship, we have calculated many molar masses. So you can just calm down. You already know how to do it. You can just pause the video and calculate. I already know most of them in my head. You get. So number of moles here equals to what is the mass? 3.65 over 36.5. That's the molar mass of HCl. Look at it. HCl. H is 1 plus 35.5. That's 36.5. So again, let's look for the number of moles here. So we have 3.65 divided by 26.5. This is the same thing as divided by 36.5. This is 0.1 mole. So it means the mole of this guy now reacted now is that 0.1 mole of HCl will now give X mole of sodium hydroxide. If you have been following attentively, you remember that I said when you have 1 and 1 here, or 2 and 2 here, whatever, if it's the same, whatever you see here will be the same, right? But let's just prove it. So we have X times 1. X equals to 1 times 0.1, that is 0.1 mole of sodium hydroxide. So it means the number of moles of sodium hydroxide that was still produced is still 1 mole. You get. Now remember, let's bring this into this place. Remember, number of moles equals to CV in cm cube over 1000. Now they give us volume in the question of what? NaOH. Because they say, what is the relation of sodium hydroxide reacted if 25 cm cube of its aqueous solution, whose aqueous solution? Sodium hydroxide's aqueous solution. So it means we already have N. Now we have calculated N as 0.1. We have calculated the volume as 25 cm cube. But let's look for what? C. So we can easily get this. You can easily get this, right? So let's solve it here. Remember that N is equal to CV over 1000, right? What is C? We are looking for it. What is V? 25. What is 1000 V? That's equals to N. That's this N. And N is what? 0.1. So if you cross multiply, we have that C times 25 equals to 1000 times 0.1. Let's just divide by this 25 here. Abi? Then we cancel out normal mass. Alright, let me take this thing down a bit. So we now have 1000 times 0.1 divided by 25. So we have C is equals to what? 4 what? Is it mole per dm cube? Yes. Mole per dm cube of, so we have 4.0. So the condition of this guy is actually what? 4.0 mole per dm cube. Now how do we know the unit is mole per dm cube? See, the function of this 1000 here. Remember I said that to convert cm cube to dm cube, divide by 1000. That's the function of the 1010. And remember, I already stated before that if V is in CM cube, use divided by 1000. If it's not, use just CV. So we shall go to calculate this question. So this is just the basics part of stoichiometry solutions. Yeah, you get it's the same logic. You compare using the moles, use whatever value. This might just be a volume value to volume. You get whatever you are comparing, you just have to compare more and then get what you are looking for. Check that. So let's take other examples. I believe as we solve more, you are going to understand more. You're going to understand better. So let's take example. Please, at any point, if you have to go back, please take video back. Okay, take video back. That was example 3. I'm going to solve. Let's see how we can do it. If time permits, and if I'm not satisfied yet, that I don't feel that you have understood yet, I don't mind solving up to 15 examples, different varieties. So we can now go to past questions after we have tested what we actually know yet, if it's correct or not. You get so. Let's go to example 4. Example 4. Right, example 4 says what is the molarity of let me think of a reaction to use. I'm going to SO4 produced from the reaction of let me change this thing. Let's see. Okay, let's just leave it. And from the next example, we can start changing this. From the reaction of 56 dmq of H2SO4 with sodium hydroxide. Yes, in brackets, volume of N2SO4 is equals to 1 to dmq. Sodium is 23, oxygen is 16, hydrogen is what? 1. Is there any other thing? No. See, this question is very short and very easy too. If you look at it, I did not give you equations because let me tell you the thing, I don't want to pamper you guys in this video course. Most of the questions you actually encounter, you will not see, what is it called? You will not see equations. That's why I said it before, that you have to know a lot of equations from organic chemistry, acid, base, and salts. And then descriptive chemistry, that's metals and non-metals. So you understand. So that's it. So let's go. Okay. Let's go solution. You have to start with the equation. Now, let's say this guy was produced. So the main equation here is H2SO4 plus sodium hydroxide giving us Na2SO4 plus H2O. We have to balance, so we have to here to balance the two in the stuff. Okay, we have H2, we have H2. No, we now have so we have H2, that's 4 hydrogen. Oxygen is actually what? 2 plus 4, 6. 2 plus 4, 6. Sulfur is 1. Sulfur is 1. So everything is balanced now. Please, let's ignore the state of matter for now. All these things will not matter in ever. Okay. Now what we have to do is this. Remember that the first thing we have to do is to compare. Look at what you are comparing. Now they give us produce on 56 dmq of H2SO4. So we are concerned about H2SO4. I will concerned about this guy, right? Because they give us something here and they are asking for something here. You get? So we are comparing between these two guys. So what I'm going to compare the first time, I'm just going to say 1 mole of H2SO4 produce what? 1 mole of Na2SO4, obviously. You get? And then we're going to look for the mass of the number of mole of this guy from the function that was given. So remember, they said was 56 dm³ of H2SO4. Right? Remember, number of moles equals to volume that is given over 2.4 dm³. You can use this. That's 56 divided by 2.4. So the goal is to use whatever they are giving you, either the mass or volume, to look for the number of moles again. I can now use to compare the second time. So we have 56 divided by 2.4. We have 2.5 moles. So we now see that 2.5 moles of H2SO4 will produce S mole of Na2SO4. Please, I don't want to waste time again. Remember, I said this is the same. So whatever we have is also the same. So it means S it also goes to what? 2.5 moles of Na2SO4. You see now, they also look for the molarity. Molarity is actually what concentration mole per dm³. You get, and you see they give us the volume of this guy here. Volume as 112 dm³. And now we are looking for the number of moles as 2.5. Remember, N is equal to CV. That's when V is in dm³. You get, you only say over 1000 when V is in cm³. I see now this volume is in dm³, so you have to use over 1000. You're looking for what? This guy. So what I have to do is to make C theory formula. C is already equals to N over V. Check. That's 2.5 over 112. You get very easy. 2.5 divided by 112. So we have 0.022 mole per dm³. You see how easy this stuff is. So this is just it. This is how it works. We are using the same number. We are comparing using number of moles still. But then what we are doing now, since we already have knowledge about mass relationship problem and mass volume relationship problem, you just bring that knowledge here. Bring that knowledge here and see how it works. Just convert. The first thing is to compare with the number of moles from the equation. The next number of moles you have to compare will not be from the information that was provided. Because we already have knowledge of mass problem and mass volume problem, it will not be hard for you. So that is it. Let's take the next example. So let's move on. This example 5, I was solving the questions. Let me just continue. This is an equation. Then asking what is the mass of CO2 that will be produced from reacting okay 30 cm³ of 0.005 mole 𝗂. Very good question, right? Ca is equals to 40, O is equals to 16, carbon is 12, H is 1, Cl is 35.5. Yes. Alright, so we're asking for the number of what? The mass that we produce actually. Now it's quite easy. You get. Now if you look at this question, it's almost, see, I want you to get the concept so that whenever you see any question, no matter how it's twisted, you still answer it correctly. Now the concept is this. Now what we are concerned about now is CO2 and then 𝗂, that's calcium triaryl carbonate 4. You get. Now what I want to do is this. We will still do the normal stuff. It's just the same comparison. We already know what you are comparing. So we can see that 1 mole of 𝗂 actually will produce 1 mole of 𝗂. But you now give us an information here. See this thing. You know how we can make this value n equal to CV over 1000. That's if volume is cm³, right? Now we can use this value to look at the number of moles of this guy. You get. What is C? Look at it. 0.005. What is V? 30 over 1000. N is now equals to what? N is now equals to what? 0.005 times 30 divide by 1000. That's 1, 2, 3, 4. Let me just 1, 2, 3, 4. So this is the number of moles of this guy that is produced or that reacted. You get, how do we get it from this value? So we now have 0.00015 moles of this guy. We actually produce. It is to give us what? X. Remember, I've said if you have one, you have one, or you have two, the same number. Whatever is supposed to be the same. So we now have that X equals to what? 0.00015 mole of what? 𝗁𝗁 that is produced. You get. Now the molar mass of 𝗁𝗁, I think is 44. Now remember, we are looking for the mass, Abi. Number of moles equals to what? Mass over molar mass. What is the mass here? Mass is equals to number of moles times molar mass. What is the mass equals to number of moles times molar mass? What is the number of moles? 0.0015. What is the molar mass? CO2 is empty as 12 plus 32. Yeah, that's 44. I was correct. So let's bring this here. We're looking for the mass now, right? So mass is equals to what? Number of moles times molar mass. What is the mass? Number of moles is 0.00015 times what? 44. Times 44. So you have that the mass of CO2 produced equals to what? 0.0066 gram. Can you get the concept? So the thing is not hard. It's not hard at all. If you just remember what we did, see, if you don't get this stuff, you should go and watch the first video. Part A, we'll talk about mole concepts. You get that number of moles equals to mass over molar mass. Right? Number of moles equals to what? Volume given or whatever over 2.4 dm3, or volume given over 400 cm3. That's this place was with cm3 volume, this was with dm3 volume. Also have that number of moles equals to CV over 1000. If CV is in 1000, it's the dm3, or CV if CV is the dm3. We also took that number of moles equals to what? Number of particles, number of substance, number of anything over 6.02 times 10 to the power what? 23. So what I have to do is just be relating this stuff, relate all of them, then you'll be able to solve all these questions easily without stress of any sort. You understand? So you see this one, now what we did, what I'm looking for, you see that question, but this time we give it to us. So you can just like keep playing around. Let's go for the next one. Though we'll do something different too. I just want to get used to the whole system, the whole logic. Okay, so that was the number 5. Let's go for example 6. Okay, example 6. Example 6. Okay, shall we? Hold on. Example 6. Alright, so let's go. Let me just quickly think about a question. Let me go about a question. Okay. What was now? Please hold on. Let me think about a question. Let me just think with acid reaction. Let's acid reaction. What volume of Na2SO4 will be produced from the titration of 20 cm3 or 0.5 of H2SO4. You get right? That's it. What volume? Give it that Na is 23, H is 1, sulfur is 32, oxygen is 16. Get this thing we have to actually create what's the equation. And the equation is this H2SO4. Now this is do I even ask the question, make it more tough. Now look at this, look at something. See, they don't give you the base, but if you're a good chemist, then you should know that this salt will produce when this guy is reacted with what? Sodium hydroxide. So now sodium hydroxide give us what? Na2SO4 plus water. Let's see if it's balanced. I doubt so. Put 2 here first, right? Let's see now. We have 2 here, 6 hydrogen, 6 oxygen rather. We have 4 here, we have 1. So we have to put 2 here. That's 6 hydrogen, 6 oxygen rather. Hydrogen is 2. Hydrogen is 2. Wait, hydrogen is 2 here. 2 here, that's 4. Wow. Let's go again. That's 4. 2 here, and that's 4 here, and 2 times 2. The oxygen is 6, 2 here, plus 4 here, 2 here plus 4 here. So 4 is 1. What have I not checked? Everything is correct, everything is balanced now. What are we concerned with? This guy and this guy. You get? That is just it. You get? So what you have to do is just the normal comparison too. We will say 1 mole of, I don't know why all of you are talking about since. But when we start doing real questions, we will not be having this 1 mole scenario. We produce 1 mole of Na2SO4. You get? That's the first part. Now they give us a particular value here. You know, we can use this. We can just CV over 1000 because this volume is the same cube. What is C? 0.5. What is V? 20 over 1000. You see, we can use this value to look up the number of moles again. That is now react from this specific reaction. You get? So we have 0.5 times 20 divided by 1000. So we have 0.01 mole. So it means 0.01 mole of H2SO4 we actually produce what? It will still give us 0.01 mole of Na2SO4. You get? Now the answer is for the volume of this guy. Remember that number of moles is equals to what? Volume over 2.4. That is to say that volume divided by equals to number of moles times 2.4. What is the number of moles here? 0.01 times 2.4 times 2.4. So we now have 0.224 dm cube of this guy. See, the concept is the same. What's just changing is what the values that we're having there. Okay, see, this stuff is very, very, very easy. It's very, very easy. Very easy. That's example 6. We can keep going on and on. Okay, let's just keep going till you finally understand that till you are tired of my examples. Okay, what have I not done yet? I've asked you to look for mass, look for volume, evaporation. Okay, let's look for volume. You get? So it's very, very easy. It's as easy as what I'm just doing now. You get? Very, very easy. You have to kill yourself to put it in red. Example 7. Example 7. Okay. And it has to do with the solution. Coming up with the solution is just what is hard for me now. Okay, let me think of one. Let's see that. Actually, equations are just case in my head. Let's say we have aluminium what now? Okay, that will be too complex. See, the formula whatever I use is not the problem. The problem is just want to understand what you are doing. Let's do this. Or let's do this. Plus H2O plus CH3. Let me show that's balanced. Definitely not. Let's put 2 here. You have 2 sodium here. Hydrogen is 2 here. Oxygen is 6. This is 3, 4, 5, 6. Carbon is 2. We have 1, 2, so it's balanced this way. Now can I ask what volume of CO2 is what volume of 0.02 mole of what? Na2CO4 will be required to produce. I'm coming up with some maths on my phone. We have 23 plus 1 plus 12 plus 48. To produce 8.5 grams of sodium hydrogen triazocarbonate 4. That's the question. They were given that Na is 23, C is 12, O is 16, H is 1. You get? Now this is actually very easy also. It's very easy. It's very easy. Actually very easy. Now, we just have to understand the question. We're looking for what the volume of this guy, right? And they give us the mass of this guy. So what we are concerned is these two. So what I have to do is this, let's go solution. We see 1 mole of Na2CO3 actually what produces 2 moles of NaHCO3. You agree, right? From the balanced equation. Now, we are looking for what is this guy. So X mole of Na2CO3 will produce from, you see this value 8.5, and remember the number of moles is equal to mass over molar mass. So we have to calculate the molar mass of this guy. We can use to look for the number of moles. So NaHCO3 is equal as Na plus H plus C plus O times 3. Then it's 23 plus 1 plus 12 plus 16 times 3, right? 16 times 3. 16 times 3 is what I 48. So we have 23 plus 1 plus 12 plus 48. If I do that math for you, 12 plus 1 plus 23, we have 84 grams per mole. So it means the molar mass of this guy is 84 grams per mole. So we have, what is the mass given in the question? 8.5. 8.5 divided by 84. You get 8.5 divided by 84. We have 0.101 mole of this guy. So you say S mole of this guy will now produce what? Will now produce 0.101 mole of NaCO3. What do you do? Because multiply x times 2. We have 2x equals to 0.101. So x is equal to 0.101 divided by 2. So divided by 2, we have 0.051 moles of what? Moles of NaCO3. What are we looking for? We're looking for the volume. But you see, they gave us relation. Look at it now. We have number of moles as what? 0.051. We have relation as what? 0.02 mole. We are looking for volume. What formula should we use? N is equal to what? CV over 1000 of CV. But now in this question, they did not specify if we look for volume in that CM cube or DM cube. So let's just go with DM cube. Now in this kind of question, how do you know the one we should use? Is it how do you know the volume we should look for? Is it volume in CM cube or volume in DM cube? Now the volume you have to look for will be determined by the parameters given, like the unit of the volume given in the options. These are how the options are in DM cube. You look for volume in DM cube. If all the options are in CM cube, you look for the option in CM cube. That's how it works. So let's use DM cube. So N versus CV, you get. We have C, I look for V. So we can say, actually, let's put it here. We have 0.051 equals to C, 0.02 times V. Divide by 0.02, divide by 0.02, divide by 0.02. So we have that V is equal to 2.53 DM cube of what? You see, that is just it. I believe with these few points of mine, with this few example, I'll be able to teach you the foundational part of this topic. Talk about volumetric analysis. Volumetric analysis. So we have talked about, we are still in stoichiometry of solutions. So for this time around, I want us to go into volumetric analysis. I believe we have seen this formula before. CAVA equals to CBVB. CAV over CBVB is equals to NA all over MB. and also C1V1 is equal to C2V2. Now, these are the questions that have to do with this formula are the questions I'm going to talk about now. Just now, the ones we did on stoichiometry of solutions, those ones they are quite different. Like normal molarity and all those things, they are quite different, but they are similar to this part. Now, the concepts here, this volumetric analysis, there are questions from what is it called, titration. I don't know if you have done titration before, but titration basically is when you react acid and a base to form salt and water. You get. It can also be that when you react acid and a salt to form salt and water. So when you are doing titration, you always know, you use the pipette for the base to seek the base, and you use the burette for the acid. Now the volume of the base most times is always known, because why? The volume of the pipette that you are using is always calibrated. You see that is calibrated as 20 cm3 or 25 cm3. If you don't understand what I'm saying, just like you carrying a bucket. If the bucket is 25 liters, it means if it's full, it cannot carry more than 25 liters. That's just the standard. So you get. So please take, when it comes to volumetric analysis, a solution whose constitution is called a standard solution. So the basic concept here is that an answer and the base will be given to you. They'll give you some information on both of them. They will ask you, look for that condition of this, whatever. Then we'll get to see it all. So please take note of this, please, that C is equal to concentration. Let me just write it that is Ca, concentration of the acid, and the unit is either 𝗁𝗶/dm³, but you can write as like something like 1m. You get concentration of the acid. Concentration of base is what? Concentration of the what? Base or salt in the same unit in 𝗁𝗶/dm³, or you get. Why is it either salt or base? It's because titration can be in between an acid and a base, or an acid and a salt. You get. Then Va is what? The volume of the acid, right? Vb is what? The volume of the base. Na is the number of what? Moles of the acid. Ymb, number of moles of the base or alkali. Do you get? That's the first formula. So why for this one? This one is called dilution formula. You get, when you dilute certain stuffs. This one is called initial pressure, initial volume, final volume too. So let's what's the basic one? Let's see how questions here work. We just start small sharp. As we progress, we just see how we can take up to 4, 5, 6 examples, so I get used to what I'm going to be doing here. You get. So let's go for example 1. Through the examples you understand better, okay? So now let's do example 1. Example 1. Say 20 cm3 of 0.05 molar concentration of HCl was titrated. It gives 25 cm3 of sodium hydroxide. What is the concentration of sodium hydroxide? You get. I will not be giving you all those values that n equals to 3. You should know them by now. Now, in doing volumetric analysis, one of the most important things you must always notice is that you need a balanced chemical reaction. Remember that formula is CaVa all over CpVb equals to Na over Mb. Now you see that N is number of moles. That's the number of moles of the acid or the base on the reaction. So if you don't get that value right, your workings are going to be wrong. Do you get? So a balanced reaction is needed there. So let's go. First of all, we have to write the balance equation. So the equation is that HCl reacts with what? This guy to give us what? Sodium chloride plus what? Salt and water. We already know the states. I don't have time to write states. So it's balanced. You can see that number of moles of this guy here is 1. So let's start with that. Number of moles of the acid is 1. Number of moles of the base is 1. We already know what number of moles is. That means this thing is 1 that is standing here. If it's 2 that is here now, we'll say this is 2. Or as the case may be, you get. And also now this is what? Is a 20 centimeter cube of blah blah this guy. The volume of the acid here is what? 20 centimeter cube. What about the concentration of the acid? This is concentration, right? It's what? 0.05. What else did they give to us? Concentration of the base. Sorry, volume of the base is what? 25 cm cube. What about concentration of the base? That's what we're looking for. You get? That's just the logic. Very, very simple at times. You get? That's it. So let's bring the formula out. Say 𝐶𝗵 all over 𝐶𝗵 is equals to what? NA over NB. What are we looking for CB, right? Let's put the value. CA is what? 0.05. What is VA? Times 20. Give my calculator not off because it's 40. All over CB. What's GB? 25 equals to 1 over 1. Because multiply, we have that CB is equals to 0.00005 times 20 times 1 all over 25 times 1. So let me press my calculator. That's 0.05 times 20. That's 1 over 25. So this version of the base is what? 0.04 mole per dm cube. Or you can say 0.04 m. You get the logic. So that's just how it is. Very, very simple logic. So it's just CAV over CM over CBB equals to NA over NB. So the thing is that they can ask us, they can give us, the thing is we can only do for one T at a time. So it means we'll have every other thing. Now you get NA and NB from the balanced reaction. You get. So let's go to example 2. Example 2. Example 2. Let's solve another example. Example 2. Example 2 says, what is the volume of 0.01 mole H2SO4 that is required to completely neutralize of 0.025 mole of sodium hydroxide. So I use sodium hydroxide again. You get that just the equation. So the first thing we need is the equation, right? We need the equation. Equation is this. The acid is H2SO4. We have to use sodium hydroxide. See, that's actually you have to know reactions. To give you this guy plus what? H2O. Is it balanced? No, we have 2 sodium here, put 2 here. By this, we now have 4 hydrogen here, and we have 2 here. So we put 2 times 2, sorry, 4. Hydrogen is balanced. Oxygen is 2 times this in 2 here plus 4 here, 6. We have 4 here. It's balanced now. So what is Na? How many? We have just 1. What about NB? NB is now what? So we see why a balanced reaction is needed. If we didn't balance the reaction, now we will not see that NB is equal to 2, and that would lead us to the wrong answer. So we'll say, what is the volume of? So we are actually looking for what? Volume of the acids. What about concentration of the acid? 0.01. Right? What is the concentration of the base? Acid here. 0.025. Right? What is the volume of the base? 25 cm cube. So with this, we can solve. We are good to go. So the same formula applies. CAV all over CBVB is equals to what? NA all over what? NB. Right? What's CA? CA is what? 0.01. What's VA? We are looking for VA. What is CB? 0.025 times VB 25. What is NA? 1. What is 2? So let's make VA so the formula. VA is equals to what? 0.025 times 25 all over 0.01 times 2. You get. So let's solve. We have 0.025 times 25, 0.625 all over. That should be 0.02 now. 0.02. Okay. Very valid answer. So we have that this thing is at 1.25 watts cm cube. So the volume of the acid that we added was what, 31.25 cm cube. Sure, you see how simple this thing can be. That's just it. The concept is very, 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 very easy. So let's take one more simple one like this before we move forward to a higher dimension or to a higher level. You see how easy it is. So the thing is, just understand the question. They can ask you for anything here, but once they can never ask you to look for on normal day is NA or NB because you always know it on the equation. But when it comes to positivity, there's a way they can trick you. You have to look for the number of moles of the acid or base you get, but not in jam level, but positivity level. Just get used to mass. It's mass knowledge that we have. Okay. So let's go to example 3. Let's go to example 3. Do you know that? Okay, let me show you something. Do you know that after I've gotten that volume now, or do you know after I've gotten? Okay, let's do one on that complexity. Okay, they said okay, let's see. Okay, 30 centimeter cube of 0.1 mole per dm cube of H2SO4 neutralizes KOH. If neutralizes 20 cm cube of KOH, that's where my dosage. What is the mass concentration of KOH? Yeah, good. You see now it's getting more complex. First of all, the first two examples I did, I have to understand the concept of the formulas. You can change anything to that, just it. Now let's go into complex cases. So that when we start doing classwork, you will not be lost. Do you understand? So what is the mass concentration of this guy? Now the first thing is that look at the equation. H2SO4 plus KOH will give us what? K2SO4 plus H2O. Is this balanced? No, this is 2 here. We have to put into here, we balance everything. Do you understand? So it means Na, number of the acid is 1, Mb is what? 2. Va, volume of the acid is what? 30 cm cube. What about Ca? Ca is what? 0.1 mole per dm cube. 0.1 mole per dm cube. What does they give to us? They give to us Vb as 20 cm cube. Right, 20 you get. They were looking for what? Cb first of all. But that's not what they will ask us before. They should look for what? Mass concentration. Remember that mass concentration is also known as what? Molality. And then remember that I gave a relationship that molarity is equal to what? Molality all over molar mass. That is to say, molarity times molar mass will give us the molality they are given for. Remember that molality is what? Mass concentration. And this is called what? Molar concentration in mole per dm cube. And it's gram per dm cube. You see where the whole stuff is starting from. So our goal now is to look for this guy first. We can calculate the molar mass of KOH, then we can get the molarity. See how it's not very complex, it's just normal work. So everything relates around stoichiometry. You just have to understand. That's why I took my time to break this video and then explain and then arrange everything the way it is here. They just took the light. But I believe this thing is still clear. So let's go on with the explanation. I'll just hold on. Let me get my power bank to power the ring light. At least that will give me a little illumination. Alright, so I've powered my ring lights. Please, sorry for the. Okay, it's still clear. The board is clear. So let's just move like this. The thing is, I've recorded this video. I'm recording it to pin because I've recorded it before. I don't know why it happened. I lost the video. I lost the file. It's deleted. I don't know. Maybe I mistakenly deleted it. So it's very painful recording it again. And now that I want to record again, if I want to see lights, this will only be. So let's move. We'll do it like this. Alright. So you see, putting out courses like this, it stresses a lot. It's not easy. You get it. So that's why I actually I don't feel that I paid to get it. That's why I'm paying to compensate my stress. Get. So now we have gotten our parameters. The next thing is to use formula. 𝗁𝗶𝗶𝗀 what's the word? 𝑁𝐴/𝑁B. What is CA? CA is this 0.1 VA times 30. What is CB? We don't know. What is VB? VB is 20, right? What is NA1, NB2? So let's make CB. So in the formula we have CB is equal to what? 0.1 times 30. That's capital of 0.1 times 30 times 2 all over 20. Let me see I can get the calculator on. That's 4. Please, sorry. Okay, I've won it. Right, so 0.1 times 30 times 2, that is 6 over 20. So the sum of the base is what? 0.3 𝗵𝗶/cube. Now this is what? The what? Molarity. You agree, right? What they ask to do for mass concentration, or this is called molar concentration. So we have to look for the mass concentration now. Do you understand? So let's look for the mass concentration. We have that. Remember I've drawn that relationship just now. That molarity is equals to what? Molality all over molar mass. That means, in other words, because multiply, we now have that molarity, which is what? Mass concentration is equals to molality, what we just calculated, times molar mass. Right? Remember this thing is 0.3. You get it? So we are looking for this. Sorry, I made a mistake. This is supposed to be molality. Since we are cross multiplying, you get this is what we are looking for. What is molarity? That's what we are looking at 0.3. What is the molar mass of KOH? K is 39, O is 16, H is 1. So it's empty as 40 plus 60, 56. Do you get? You can do it slowly, but there's no time. So this is 56. So we have 16.8. So the molarity is what? 16.8 what? Gram per dm cube. Which is what? The molality or mass concentration. Should you get it? It's as easy as this. Very, very easy. So let's go to let's take example. This was example 3. Let's take example 4 now. Let me just show you how potential questions will come. Now remember, okay, when I drop it, you remember. Let me drop the question. Example 4 now. Example 4. Two grams of sodium hydroxide in 100 cm³ of solution add 25 cm³ of it reacted with 20 cm³ of HCl. What is the molarity of HCl reacted, question mark. Now, this is a basic concept too. First input equation, HCl plus NaOH, give us what? Sodium chloride plus water is balanced. You can put the state by yourself. Now, the first one to note is that Na, number of moles of the acid is 1, and Nb is obviously 1. What about, let's talk about the acid. They give the Va, right, 20 cm3. What about Ca? That's what we're looking for. What about Vb? Right, 25. Please take note, this is what? This is what? This is the volume. You get, not that 100 that was written there. You get, so Vb is what? 25 cm3. Then what about Cb? Now we don't know yet. You get, we don't know what our, let me see, is this thing clear? Yeah, it's clear. Let me bring it closer. I don't know why they do this light. Okay, so that's how. Now what we for Cb? Remember that time I dropped one formula that to look for condition in mole/dm3. We know in this place we need condition in mole/dm3. I said the formula is mass times 1000 all over the volume times the molar mass, right? What is the mass here? 2 grams times what? 1000. What is the volume here? 100 times what? Molar mass of sodium hydroxide. We have done it many times, so let me do it again. That's 23 plus 1 plus 16. That's 40 times 40. You see, so this will give us 2000 and this will give us 4000. Get? That will be 0.5 mole/dm3. So that would be the molarity here, 0.5 mole/dm3. You get? So Chase, so when you are giving things like this, remember this, we have done this thing before. So you have to convert this guy here. This is well, we have to convert it to what? Mole/dm3 before you use it. Then you do normal solving too. Do you understand? So that is it. I'm just worried about this, if you can see this video clearly. I hope you can see it. I will try to make my writing bigger. So we have CaVa all over CbVb is equals to what? Na/Nb. What is Ca? That's what we're looking for. So C, what is Va? 20. What is Cb? 0.5. What is Vb? 25. What is Na? 1/1. So we are looking for, let's make Ca such a formula. We have 0.5 times 25 all over 20. So we have 0.5 and 25 divided by 20. So we have that Ca is what? 0.625 mole/dm3. You get, so that is it. That was example what? That was example what? Is it 4 or 5? I don't know. Example, let's take that as 4. You get, so what made this question a bit different is the fact that they gave us something like this and we have to look for the condition in mole/dm3 by ourselves. So there are many questions like that. You get, so let's move to example 5. So I just put example 5 question on the board, and the way you see is 30 cm3 of 0.2 molar concentration of H2SO4 was found to react with 20 cm3 of KOH solution, which was formed by dissolving 30 grams of KOH pigments in 500 cm3 of water. What is the molar concentration of KOH that was saturated? It's easy. First is the equation. Equation is that H2SO4 react with what? KOH before what? H2SO4 plus what? H2O. Check is balanced. So we have that Na is equals to 1. Nb is what? 2. What is Va? Va is what? 30 cm3. What is Ca? Ca is what? 0.2 molar pressure. What is do you know that this is Vb? Yeah, that is Vb. What is Cb? That's what we're looking for, right? What is Cb? Okay, I'm looking for Cb. Do you know that the major thing I want to do is that I just deceived you by giving you these values here? Do you know why? Because we are looking for Cb. They are simply looking for molar concentration. And molar concentration is what we are looking for here. We can get it easily. So you don't have to, there's no point converting this stuff. I don't know if you understand. Do you know you'd have converted this if we're looking for CA? It was not given. Then you wanted to just fit this value here. Then you convert this into 𝗁𝗶𝗀𝗃. So this is easy. Just do it like this: 𝐶𝐴 all over CB VB is equals to what? LA/LB. We're looking for what? CB. What is CA? 0.2. What is VA? 30. What is CB? We're looking for it. What is VB? 20. What is LA? 1/2. So let's go for CB. CB is what? 0.2 times 30 times 2 all over 20. We have 0.2 times 30 times 2. We have 20. We have that what? CB is what? 0.6 𝗁𝗶𝗀𝗃. Is that not the molarity, molar condition? That is it. Just like that. Now I want to tell you guys something also. Something that they might likely ask you. Because many people are used to a certain pattern. What if you are giving, let's say, we used to convert, I gave you a formula to convert whatever to 𝗁𝗶𝗀𝗃. Now I said condition in 𝗁𝗶𝗀𝗃 is equals to mass times 1000 over the volume times what? Molar mass. Do you know that this should be done only when we're talking about 𝐶𝗵⁵? So if you have something like 30 grams of QH pellet was dissolved in 50 dl³ of water, how do you convert this gram per dl³ to 𝗁𝗶𝗀𝗃? It's easy. You will remove this 1000. Do you understand? So please take that the function of that 1000 is to convert CM to dl³. So this is dl³. Don't use 1000 again. So when you have CM³ then use times 1000. That's the logic I want us to understand. Then let's take one more example. I'll be example 6. Example 6 says 20 cm³ of 0.1 𝗁𝗶𝗆 was diluted. What is its new concentration if its U volume is 30 cm³? That's just based on what is it called? Dilution. I don't know how to do one example. Look at C1 is this value. C1 here is the first condition, 0.1. V1 is this first value 2. Right? V2 is what? 30 cm³. What is C2? We don't know. So this is what? 0.1 times what? 20 equals to C2 times what? 30. So we have that 0.1 times 20 all over 30 is equals to C2. You get it. So 0.1 times 20 divided by 30. So that is C is equals to 0.067 𝗁𝗶𝗀𝗃 or 0.067 get. So that is it. So another thing I want to do is that there is something known as dilution factor. So if you ask me for the dilution factor, just do V2 over V1. Sorry, V1 over V2. Do you get? So just divide this, you get your answer. So guys, that's it. The next thing we're going to do now, we're going to go to past questions and see jam past questions on these aspects. So just please hold on. If you don't understand, watch the video again. Go and solve questions with your textbook. Then follow the video on jam past questions. See you. So we are going to take jam past questions now on this part that we just did. That's acid-base titration, and also that's what we call volumetric analysis, right? And dilution. Get. So if you do not understand what I explained before, please see this part of the video is not for you. If you don't understand everything, just go and watch that one again, or this same video. I mean, just take it back take it back so you understand better. So let's go. We'll just take a past questions now. So I'll just write the past questions on the board as usual, and then sort them out. Right. So this is the first one. I don't know which past question is. Let's just write that as a past question. It's basically why a past question, but I don't know which yet. Okay, it says 25 cm cube of a solution containing 1.33 gram of sodium 𝗧𝗵𝗁 in 250 cm cube requires 24.5 cm cube of a solution of H2SO4 for complete neutralization. Okay, what is concentration of what? The acid. Given the options that option A is 0.01 mole per dm cube, option B is 0.03 mole per dm cube, option C is 0.05 mole per dm cube, and option D is 0.07 mole per dm cube. Yes, so I think I just have to use this red marker because I think it's working best. Okay, solution. Okay, so I'm going to reserve this part to serve as assist when solving. So let's write out the parameters. That's the stuff that we're given. We know that. Let's write out the equation first. This is the equation: H2SO4 plus NO2CO3 will actually give us what? Na2SO4 plus HCO plus CO2. Actually, let's see, is everything balanced? We have 30 here, 3 plus 4, that's 7. Everything is balanced, right? So what are you giving the question? You get this 24. This is the volume of what? The acid. So volume of the acid is 24.5 cm cube, right? We are actually looking for the concentration of the acid. Volume of the base is 25 cm. No, this is actually the other type of titration that I was talking about. You know, we have two types of titrations. We have one that is acid-base titration. Then we have acid and salts to produce another salt, and then water and carbon dioxide you grab. So this is the other type. So this salt you actually call it the base here. You get. So we have 25 cm cube. Then what is the volume of the base? Sorry, concentration of the base. We don't know yet, but we can actually know because they give us some values that we're supposed to know. Remember, they said it contains 1.33 gram of this guy in this. Remember that our formula, that concentration to get concentration of more in mole per dm cube directly. Just do mass that is given times 1000 all over the volume times the molar mass. Remember that the molar mass of Na2CO3 is 106. We have admitted that so many times before. What's the mass here? 1.33 times 1000. What is volume? 250. What is the molar mass? 106. Please give me 1 minute. Let me get calculator. Okay, so let's go. 1.33 times 1000. That should be 1,330. 250 times 106. 130 divided by this answer. We have that this thing is. We have that our concentration is concentration of the base is actually what 0.05 mole per dm cube. Okay, that's it. 0.05. So what I'm looking for now is the volume of, say, concentration of the acid, right? So now do this CAVA over CBVB is equals to NA over MB. What is CA? We are looking for CA. We are looking for CA. What is VA? VA is what? 24.5. What is CB? 0.05. What is VB? 25. What is NA? 1, you get 1 over 1. So for me, we have that CA is what? 0.05 times 25 times 1 all over 24.5 times 1. So we have that CA is equals to what? 0.051. So CA is approximately 0.05 mole per dm cube. And that is what? Option C. You get option C is very correct. Alright, so that's it. So let's move to example 2 or class work 2 or pass option 2. Whenever the case might be, UTME 9091 question 3. UTME 1991 question 3. And here's what the question says. It says, sorry, question 22 rather. Question 22 says, what volume of CO2 at STP would be obtained by reacting 10 cm cube of 0.1 molar concentration solution of anhydrous sodium triiosocarbonate 4 with excess acid. We have A, option A as what? 2.240 cm cube. B, 2.40 cm cube. C, 224.0 cm cube. Option D, 240 cm cube. So let's solve. Solution. Now, first thing I want to do is to okay, now look at it. We're looking for the volume of this guy that's produced by granular with acetic acid. Now they did not mention the particular acid. You get. They did not mention what the particular acid. You get. But whatever the acid will be, it's not going to affect the stoichiometric ratio of 𝗶𝗶. Try it. Use a monobasic acid. Use ACl. Use H2SO4. The only thing that the acid, the choice of acid you use, the only thing is going to affect is the stoichiometric ratio, or the number of moles of the salt that is produced, or of the what is it called? Of the salt that is produced. That's what it's going to affect. It can also affect the amount of the anhydrous sodium triiosocarbonate that will be reacted, but it's not going to affect the amount of the 𝗁𝗶 you get. So in this case, we want to assume that like we produce 1 mole of 𝗁𝗶, and we are reacting 1 mole of what? Anhydrous sodium 𝚎𝚎-4. In case you don't know, anhydrous sodium 𝚎𝚎-4 is Na2CO3. They have the molar mass of 106. You get. So what we're doing for now is the number of, we already assume that the number of moles will be equal. You get. So the first one to do, this is not a complex case. Number of moles equals what? CV/1000. That's if the V is in what? Centimeter cube. So we have C as what? 0.1 times V 10/1000. So we have what? Let me first calculate. That's 0.1 times 10 divided by 1000. We have 1 times 10⁻³ moles. Remember, this is still going to be what? The number of moles. Let me write it here. So the number of moles of this guy, Na2CO3, will still be the number of moles of 𝗁𝗁. So it means the number of moles of 𝗁𝗁 is actually what? Also equals to what? 1 times 10⁻³ moles, right? Now having said that, remember the number of moles equals to what? The volume, whatever given or whatever you're looking for, all over 22.4 dm cube. That's if the volume is dm cube here, or the volume over 2400 cm cube. Now if you check out the options, they are in cm cube, so we use this one. So if you cross multiply, you see that the volume here is equals to number of moles times 2400 cm cube. You get. What's the number of moles here? 1 times 10⁻³ times 2400. You get. So the answer is what? 22.4 cm cube. And that's what option B. So that is it. It is as easy as that. Okay. So that is. Let's move to what? Example or past question 3. Alright, so we have the 4th or the 3rd, I don't know, next classwork or past question on the board. So I'm just going to solve it now. They said given that now the first thing we want to do is to write the equation, right? Though if it's me normally solving this, I will not write the equation. I'll just I was trying to explain something to you guys before, but seems that many of you would understand. That's why I'm just writing the equation. With me personally, I will not write any fucking equation. I just, from seeing the two reagents, the acid and the base, I already know the number of moles of the acid and the base you get. But since you're still getting used to it, let's write the equation. You get H2SO4 plus sodium hydroxide give us what? Na2SO4 plus what? H2O. What do we need to balance? This guy. So actually you can see that from the equation, VA, volume of the acid is 15 cm3, right? While VB is what? 25 cm3. While CB is 0.125 mole per dm3, right? We are looking for what? CA, right? Na from this equation is 1, NB is only 2. So CA, VA, all over CB, VB is equals to what? NA over NB. So we are looking for CA, right? So it's CA times what is VA? 15. What is CB? 0.125. What is VB? 25. What is NA? 1 over 2. So you can see that. Let's bring it here. CA is actually equals to what? 0.125 times 25 times 1 all over 15 times 2. And that is what? That is equal to 0.125 times 25 times 1 divided by 30. That's 0.104 mole per dm cube. Is that in the option? Yeah, that's option C. You get. It's as easy as what we just solved. Right. So let's go to the next past question. Can you see how easy this thing is? So I've used the examples to actually explain almost everything. So you just need to see questions, think about which of the cases it falls under, what are they asking you to look for. So get your answer, that's your exam. Okay, so that was question what? Let me go for the next one. Okay, it says This is what? 𝗁𝗵 9080 question what? Question 7. And it says if 1 liter of 2.2 molar concentration, okay, 2 m's of sulfuric acid is poured into a bucket containing 10 liters of water, right? And the resulting mixed thoroughly. The resulting sulfuric acid concentration will be A 2.2, B 1.1, C 0.22, D 0.11, E 0.20. That's it. So let's go solution. Now this is not any 𝗂𝗵𝗶𝗀𝗶 or rubbish. This is actually what dilution was formula method to get 𝗁𝗵 equals to C2V2. Remember that I said V1/V2 is dilution what factor, right? So now that one does not really concern this question. Now look at this. What every Jambite we want to do at this point is just to say, okay, V1 is 1 liter, right? So V1 1 liter, right? C1 is 2.2, and then they will say, okay, V2 is what? 10 liters from the equation. Why? C2 we don't know. Then that's the C1 V1 equals to C2 V2, and then C 2.2 times 1 is equals to C2 times 10. Then that's the C2 is what? 2.2 divided by 10, that is 0.22. This is what every time I want to pick, and this is what actually what wrong. Solving that shows that you actually understand what the question is saying. Now, for example, if I have two containers, let's say this is a marker, I have 5 liters of ink here, and this one, I have 5 liters of black ink here, and I have 1 liter of red ink here. If I mix this black ink with this red ink, I'm going to have 6 liters of the solution or the mixture of what? The black ink and the red ink. Do you get? So the total volume will now be what? 6. That's something that we're going to do here. Look at it. Now they say 1 liter of the acid. This was the initial solution. It's now poured into a bucket of water containing 10 liters of water. So if it's poured into it and it's now mixed, it means the 1 liter of the acid has mixed with the 10 liters of water. So the resulting solution is now what? 11 liters of this acid that has been dissolved. You get? So what we do is that C1, we know it as what? 2.2. V1 is what? 1 liter. What is now V2? 1 liter from the acid plus 10 liters of the water. That is 11 liters. You get? What is now C2? We don't know. Then we can now solve. C1 V1 is equal to what? C2 V2. What is C1? 2.2. What is V1? 1. What is C2? We don't know. What is V2? 11. So we can say C2 is equal to what? 2.2 all over what? 11. And that's what? 0.20. That's option E. You get? That is the correct answer to the question. So let's go to the last one. Oh, the last one is not showing. Okay. Then to the one I wanted to draw before. Alright. So let's we have already done all of them. We have done all of them actually. So we've solved all of them. So you see, it's not as easy as you think. It's just for you to have an understanding of what the question is talking about. So I would strongly recommend that you play this video again and learn these concepts of what I just explained. Do you get? So that's it. See you in the next video, which should be on SS and limit region. That will be very, very short because there's no, we don't have too much work there. I'll just use one like start by explaining the concept, then go to past questions, and that is it for the stoichiometry course. Hope you have been gaining value so far. At any point if you don't understand anything, please go back to the videos. The videos, they are very explanatory. That even my greater and greatest grandmother, wherever she is now, if I actually teach her this, you understand too. So it's not you that is in the 21st century that don't understand. So that's it. Thank you very much. God bless.